Hello again. So this is our next module in exploratory data analysis course. So this video is very important because of the title it has, because it says us how to get the data which is used for training and testing our models. Okay, so that is the very important step in which we have to collect the data which will later be used for training our models and then evaluating the performances of the models and comparing its performance with the other models. So this is the fundamental course or the fundamental video in our data analysis course. So the first step here is that what are the different steps in getting the data. So either you have to create your own data set, or you have to download it and then access the data sets, or you have to use packages, Python packages or libraries like pandas for loading the data sets. If you are easy with the Kaggle data sets, then you can also download the Kaggle data sets, and then other libraries like scikit-learn, keras and seaborn, tensorflow, pytorch, all of these has their built-in libraries or their built-in data sets which can be used for training and testing the developed models. So first is first here. So creating own data set. So let's talk about the data set creation by your own. So if you have your own recording modules, like for audio data sets you have the studio environment and hi-fi mic, so you can easily get or create your own data sets by using all the amenities which you have. So in order to create your own data set, first of all you will collect all the data sets, and then you will have to make separate them in training and testing data. Okay, so let's have let's have an example in which we have here the folder in which we have two modules or the two folders here. The first one I called it positive, and the second one here I called it negative. Okay, these are two separate directories in which I have randomly put some data. So in order to play with them, I am going to label them. Okay, after collecting your data, what is the first step? The first step is to label them. Okay, so the first step here will be let me use the markdown here. So the first step after getting data is to label them. Okay, you have to label your data. So in order to label them manually, the thing here is that you have to get into here the positive and you have to label them manually. Like you have to come here and rename them manually, like positive 0, positive 1, positive 2. Okay, similarly after iterating through all the images here, you have to come back here into the negative images and then you have to label them as well. So that will be a very tedious task. So in order to label them, as I have told you in the recent videos, I have another module which is called the OS. So in order to label them, let me import the OS module. So as I will import this, so importing OS module and then coding it again, and let me see the current working directory. Print os.get current working directory. Okay, so what is the current working directory? This is my current working directory, but I need the current working directory to be this desktop. Okay, because my file is over this desktop. So let me create the current working directory as this one. So let me create a path, and the path here is, let me call it C, and then users, then the name here, and then this one, then this one. Okay, and then my file here which is the training file. Okay, so So now let me remove it and just call it this one. Okay, so now let me make this my path, and after creating this one, let me use another command here, which is the os.ch directory. Okay, so current working directory is changed into this path. So when it is my current working directory, let me check it also. So os dot get current working directory here. So now that is my current working directory. So okay, in order to access inside of this folder, now let me use here the inside or train underscore path. So train path here, let me call it training, and inside training, okay, so train path, or let me call it positive path to training, and then positive, and similarly negative underscore path is training and negative. Okay, so once these are created, let me join it with my path. So in order to join them, let me create a path underscore positive. So the positive path, for creating positive, I have to join this path, positive path, with my current working directory. So in order to do that, os dot path dot join. Okay, so what I have to join for the positive, I have to join my path with the positive path. Okay, so it would be my positive path. Similarly, path underscore negative will be equal to os dot path dot join, and here it will be what it will be, it will be path and joined with the negative path. Okay, so let me run it. So when I will run it, it is running without an error. So now I have to iterate over these paths. Okay, I iterate over these directories here inside the positive, and I have to move one by one over these images and write them positive 0, positive 1, or positive 1, positive 2, positive 3, positive 4. Okay, similarly here I have to move inside the negative images, and then I have to write negative 1, negative 2, negative 3, negative 4, and so on. Okay, so what I have to do now, I have to make each positive and then negative as my directories, and then by using the lister command, I have to iterate through all of these directories. Okay, so let me now go inside another code block. So now here os dot, so let me, so for positive examples labeling. Okay, so what I have to do, I have to os dot ch dir, and what is the directory now, as I have to go inside the positive images. So path underscore positive. Okay, so that is my directory now, and what I have to do, I have to move inside of it. So for I in list dir, okay, sorry, this is the os module, os dot dir. Okay, I have, as I am inside of it, so what I will do here inside of it, what I will do, os dot rename I with the what positive and plus str count. Okay, what is count? Let me see it later on, as all the images are now in jpg format, so dot jpg. Okay, so count here is, let me define here, so let me define here a counter in which count equal to 1, Okay, so after each iteration this counter will be varied. Initially the value of it will be 1, and after it will be increased, and now I'm using a string here because that is what I have already shown in the OS tutorial. Then count equal to count plus 1. Okay, so that is for my positive examples. Similarly, if I have to now label all these things for the negative modules, what I have to do, I have to use the same here, but for the negative modules, let me move down here, I have to use here the negative. Okay, and similarly changing path, sorry, to the negative here, because why am I doing it? Because lister always work for the directory images. So if the directory is not changed into this one, it will only iterate over this. I will only iterate over through the other directory. So I have to change it. Excuse me. So now let me change it to the negative. Okay, so now that's it. Now let me run it. So what is it? The system find local path training positive. The system cannot find the path specified training positive. What is this here? Sorry, this is the training data. Okay, that is basically the missing here. Let me change it here now. This is, yes, this one. The name of it was training data. Similarly training underscore data. So now this one, and now you can see that it has worked properly now. So now when I will move inside the negatives, okay, now you can see that all the names have been changed into -1, -2, -3, -4, and so on. Okay, up to -77. Similarly, all the positives have been changed to +1, +2, +3, 7, and so on. So that's it, and I can easily show you that how to label them manually. It is for what I've used. Similarly, I can use here underscore. Okay, similarly underscore here, and now running it again. Okay, now I can see here that these are now +_1, +_2, and up to the all the elements here. Okay, similarly in the negative order here. So that's the manual labeling, which I have earlier seen in my OS libraries, but now you can create your own data sets. First of all, you have to collect it, and in collecting your data sets you have to be very cautious because you have to select the environment which is noise free. Similarly, all the equipment should be hi-fi. Okay, so after collecting you have to label them as I have labeled it here. Some examples will be positive, some will be negative, so you have to decide yourself that which examples will be positive and which are negative. Similarly, if you are using cats and dogs classifier, in which cats and dogs images are used, so then you will use here the cats images, and similarly for the negative you can use dog images, and similarly so on. If you want to classify, or if you want to detect the dogs, so your positive will be dog and your negative will be cat. Similarly, if you want to recognize the cat images, so your cats will be positive and it will be negative, and vice versa. Okay, so it depends all upon you. Similarly, in my example here, I have recently developed a data set which is composed of some speech signals. So that is the corpus, or a corpus is also a database. So in this corpus I have some English, Japanese, French data sets already available. So in order to develop it, I have used some standard words from the Pashto language. So which contains some season's name and all the digits from 0 to 25. Similarly, in recording it, as I have told you earlier, that you have to select a noise-free office environment and a better recorder in order to get the higher quality. Then you have to use some editing after it. Okay, so speaker selection, your speaker selection should be in such that there should be no biasing in terms of the ages or in terms of the accent, genders, or different origins. So your data set shouldn't be biased. Okay, so in order to make it very unbiased, I have used most frequently Pashto noun, season names, name of the weekdays, and similarly all other speakers were selected which are of different ages, regions, and genders. Okay, speaker attributes were those were divided in terms of their ages, genders, and origins. Similarly, these ages were divided into 4 groups, and the age-wise distribution can also be shown here in this pie chart, and gender-wise distribution is also shown here. Okay, so as male speakers were somehow greater than that of the female speakers, but the difference is not that much, and I used it without any biasing here. So native and non-native speaker, 50% of native and non-native speakers. So I have also illustrated here the native languages of all the speakers. Then after it, what was the database organization and how I organized the database? It was like this one. All the files here, or the audio files, were labeled like in order to portray all the information available which I have used for the recording. So that is the this is all the labeling format which I used. Okay, so this is the age information, name information, gender information, and similarly word number. So that's it, and that is all about the manual data correction or creating your own data sets. So that is all about the manual data set. Okay, so thank you so much.